me check. Yep, I didn't do any work on either of these. Now, some of you are noticing there is no section 10.2, but guys, there was never a section 10.2. Okay, just kidding. There is in the book. There is in the book, but there is no section 10.2 as far as what we did. We skipped it entirely. It is not on the test. The only topics, the only sections on the test are what are right here in your review. Let me go ahead and zoom in so we can see it. So you guys do have, from the book, you have some examples up here, some little reminders, etc. But then down here, for those of you that were gone yesterday, did I miss anyone? I got Everest, I got Sunny. Was anyone else absent? Angie, you just came in a little late. Everybody else has a skills practice? Okay. I gave you my way of remembering it, and it's short, because the long version is in the worksheet for section 10.1 that you guys can go back and review, right? But I gave you my version of how do you find domain. Domain, you set the box, the radicand, greater than or equal to 0. We did that here. I just didn't put the box around it. In that, all that was underneath the radicand was x, so therefore 0, 1, 4, 9 were perfect. But this one was a little different. I had an x plus 3. Where I needed to move, I needed to subtract the 3. That was my domain, x greater than or equal to negative 3. But what does that mean about my table? Where am I going to start it? Negative 3. And some of you remember from the quiz or from the section 10.1 or even from the comparison language that we're taking that 0, that 1, that 4, that 9 and moving it left 3, subtracting 3. 0 minus 3, 1 minus 3, 4 minus 3. So did you guys finish filling in the table correctly and get negative 3, negative 2, 1, and 6? Did you guys fill in your x's correctly? Once you did, what did you get for your y's? When you plugged in 0. Plugging in 0. Now guys, the answer key will have all this detail. You were supposed to work on it last night, so I'm only going to show a few and then finish filling in. Because you would just keep going. It's on the answer key, it'll be posted. But what do you do first when you plug in? Do you do the addition or the square root? Yeah, what is the square root of 0? What's 0 plus 7? You guys fill it in right? 1 plus 7 would be 8, 2 plus 7, square root of 4 would be 9, and 3 plus 7, square root of 9 would be, you guys get it? So then when you came to graph, did you see it swooping? Where was our 7? Here-ish, right? And then 1 was 8, and then 4 was 9, and then 9, where is he? There he is, was 10. Did you guys get your swoop up? Did you put your arrow? And did you realize this point holds the key for not only our domain, x is greater than or equal to 0, but also our range. Range says not an x, but a y. And is it going up? Would you be traveling uphill on this, or would you be traveling downhill? Uphill. Uphill. So therefore, greater than or equal to 7. And do you remember the domain trick? Maybe you might want to, in a color pen, write this down. The domain trick, only for domain, because it's the right-left, you can use the arrow. Let me get a different highlighter up here. You can use the arrow to tell you which way to go. So which way is the arrow pointing? To the right. Which way will the inequality point? To the right. Cool little trick. Only works for domain, but the way that you're pointing is the same way that your domain arrow should point. And then y, just think of it going up or down. Now, this whole compare guide. Some of you guys in your worksheets, either in class yesterday or after school or during period 7, you were remembering that this whole comparison thing was that big old table that I put on the projector during your guys' quiz. Is this it? Yeah. And I'm going to put this on the projector during the test as well. I'm actually copying it right now. I'm putting it down here next to your review so I have it ready. So this whole comparison language, can you guys look at this and double check what you filled in the blank for when I said down here, compare to, right? Compare to, now, oh, I made the same typo. I meant to fix it, and I still did. Don't worry, on the test it'll be better. Compare to. There we go. And compare to. But we're totally able to use that table as far as what's going on with this guy. An addition in the outside. Okay, an addition in the outside. Which one is that? Oh my goodness, it's the exact same one. Check it. Go see. Do you guys get that it was a shift up 7? Did you look at the table? Are you going to look at it tomorrow in the test? I hope so. Do you see it? Plus 7 on the outside. So, that guy was just a shift up 7. Went the wrong way. Sorry. Let's go back. Okay, that was just a shift up 7. check out the other guy. We already figured out the other guy. Move left 3. We got that. But there are 2 more things. Did anybody find one of the other ones? Andrew. Good. It was a flip over the x because there was a negative on the outside. And we'll look at that in the table in a second. And then what else? There was one more. Shift down. Did everybody else get that? A shift down. 1. And I can show you here. There was a negative on the outside. Now, some of you guys in your worksheets, you never wrote down the table like I did in class. And so, what do you have to study from? I mean, you have the notes online on Google Classroom in like 3 different places. So I saved it one day and then I saved it another day. Anyway. Some of you aren't using your resources. Anyway, negative on the outside. Flip over to x. Perfect. And then there was also a subtraction on the, oh my goodness, look right there. Down one. A subtraction on the outside. Okay, that was, oh, nope, there was one more. Wasn't there one more big old comparison one at the bottom of that page, guys? You didn't have to graph it. You didn't have to do a table. You just had to talk about it. So, when you guys are doing this one, I'm not going to look at the table for this one. But if you guys want, for the practice test, I can, in today's announcement, where I put the key to the practice test, I will take a picture of the table and I'll put it in Google Classroom so that when you're taking the practice test, you can be staring at it. Would that help? Okay. Because that's exactly what you get to do tomorrow for the test. You get to stare at it. Well, the whole test. Hopefully you're taking the rest of the test too. But when you're looking at this one, let's just double check how you did. Actually, this one probably shouldn't have been first. There's no particular order. I wouldn't judge you if you put it in a different order. But I'm just looking what comes first is the 1/4. Did you guys figure out there was a vertical shrink? By, what would I put after that? Which one is the shrink? The +2, the -6, or the 1/4? Yeah. It's vertical because it's on the outside. It's shrink because it's, well, it's cutting it in fourths. Of course it's shrinking. It's going down. But then you also have a shift left. Ooh, not left. Actually, this one's going to be a shift right. And a shift up. But I haven't given you which numbers on purpose. Which one's the right and which one's the up? Right is 6 and the up is 2 because it's all about where it is. If it's on the inside, it's going right left. Like the people inside in and out are going back and forth. If it's on the outside, it's going up or down like the people in the line. We're moving with that little thing. Otherwise known as a tablet. Otherwise known as the menu. All right. Remember, that answer key will be online. Now we're going to this next section. Guys, how did we do? And I'm hoping this section was so, not easy, but easier. Was this section easier? Yeah. Which ones do you guys think were easiest? Let's go for those first. The last one? Sure. -6. What do we do when we have a square root? One of the most important things in the entire chapter. Oh, there is a square root. What do we do? Yeah, raise it to the exponent or square it, whichever way, as long as you know how to do it. Wait, this is so illegal in algebra in so many ways. What do I need to do? Both sides, yeah? Yeah. Okay, so the square cancels out the square root, and I end up with 5x equals +1. Oh, easy. So x equals someone be amazing and tell me whether to box it or whether to check it. Why should I check it? Ooh, because it might not match. Is that something that's up here? A quick warning? Some of you are like, box it. That was easy. I'm done. But wasn't that also the last question? Isn't the last question usually one of the harder ones? Now, I'm not saying on the test the last one's the hardest one. I'm just saying in this one. Was it really that easy? The last question? No. How do we check? Plug it in. And on the answer key, I think I do a little squiggle line just to separate the work from the check. Caleb, make sure you're paying attention. This one's tricky. How do we check it? We plug it in. So let's plug it in. And you're like, oh, of course it's going to work. Come on, we did all the math legally. You even did it for us. With us. Does this work? No. Wait, isn't this 5 over 1? And isn't that just the square root of 1? Isn't the square root of 1 just 1? And isn't 1 plus 6 not 5? What happened? why not? In the answer key, I think I do a little something like this. And I circle this, and I circle this. And I say, can a square root ever be a negative number? That was so tricky though. Like whatever, I ignored the square root because I squared. But a square root can never be a negative number. Now, that could have been really hard, or this could be really hard for your brain to see. The square root is a negative, like that was so tricky. I was just thinking of solving for x. I wasn't focusing on whether or not it was legal to be a number. But what's going to fix that, or what's going to catch that, or what's going to stop you from boxing the answer on the test? So is it annoying? Yes. But will it save you from giving the wrong answer when the correct answer should have just been no solution, or doesn't work, or impossible, or something just to tell me, no, there's nothing that works. If you want to be super snazzy, I think on the answer key I put the word extraneous, because that's this type of solution. It's an extraneous solution, meaning it looks good, but it's totally not going to work. So maybe on the test you see a square root that equals a negative, and you're like, you're not going to trick me, it's impossible, no solution. That's perfect. I'll give you full credit. If you see a square root equal to a negative and you say no, awesome. But if you solve it and you check it and you figure out it's a no, you also get full credit. And if you solve it and you box it and you don't realize it's illegal, well, then you're going to miss some points. I'll probably still give you some if you find the right wrong answer. But checking is going to save the day. Okay, now, you guys are going to probably be a bit paranoid on all the rest, being like, maybe they're all wrong. But look in the answer key. I checked them all on the answer key. I'm not going to check them all today for sake of time, okay? I'm going to tell you whether or not they're extraneous, all the rest of them. What's another easy one? Okay, that one wasn't so easy. 10? You ready? Danny, what was the next one that you thought?
11.
Yeah. Oh, really? Okay, I thought number 12 was the next easy. But 11 and 12, it depends on your brain. 11 is kind of easy if you understand it, but it could also be kind of hard. Get my squared. Did you guys get 100 for number 10? Awesome. Because you get x is equal to 10 squared. 10 times 10 is 100.
Ooh, that's cool.
Danny, why do you think this one was easy? What are you able to do to both sides?
Cube.
Yeah, it's a cubed root, so we're going to raise it to the third power. Squared root, raise it to the squared power. Well, second power. Cubed root, raise it to the cubed power. No big deal, that takes it away. We end up with x minus 1. 27. 9 is 3 times 3 times 3. 9 times 3 is 27. All I gotta do is just add 1, and I end up with x is equal to 28. P.S. Neither of those are extraneous. You can plug them in, they'll work. Armando. Well, look at the radical. What's inside the radical? The 3. So whatever, you see it? Right here. Right here. There's a 3. So then when we get to this one, no 3. Therefore, we're only raising it to the second power. And when we raise it to the second power, this one's awesome because both of the radicals go away. And we just get to write 5x minus 9 equals 4x. What, Jerry?
You already answered.
Oh, you already got it? I think I would have subtracted the 4x, added the 9, but either way, can I do a dot, dot, dot? X is 9.
Yeah.
You guys agree? Move the x terms, combine the x terms. You could have also subtracted the 5x, gotten a negative x equals negative 9. Move the negative to the other side, and we're good. That one also is not extraneous. Sorry, in my head, I'm plugging in and checking, and it works. Number 13. All right, a little bit harder. I actually think 14 is easier. Do you guys want to go to 14 or 13? 14. All right, let's do 14. So, 14. I just got a yellow highlighter, and I totally have to put it away. Why can I not do a squared yet? I gotta get it by itself. Okay, so go legally. What do I have to do first? Okay.
34.
And then divide. You have to add or subtract. Undo any addition or subtraction, then divide. Did you guys get 24 to divide? By 8? I'm doing all of this work to get the radical alone because as soon as I get the radical alone, what can I do to both sides? 3 times 3. Just slow down a little bit. Did you guys end up with 14? Double checking in my head. It works. Yeah, it was homework last night, which is why I'm going fast. Number 13, both sides. Whoa, so those of you guys that didn't totally do homework last night, you could be doing it with me and have 100% when I check it in about 30 seconds. Just kidding, we have to do one more page. About 2 minutes? I'm just saying, some of you aren't so smart. If you haven't done it, you should be doing it now. Not saying that's the best way. The best way was to do it on your own, and now you're just like, I'm getting it. That was wrong. I better study that for tomorrow. That's what right now should be like. But just a few of you, huh? Why was this one harder? I have to factor. Awesome, Danny. Good vocab. I have to factor because I have a square. Okay, do you agree? Am I supposed to factor right now as it is with stuff on both sides? No. Did you guys move this stuff to the left? You might have done it in different steps. That's totally okay. I'm just being a little lazy and fast because you were supposed to have already done it. And I'm moving it all at once. What do you guys use? A table? An X? Awesome. So the X? Did you complete the square? You could have. Although you would have just moved. That would have been.
I used something else.
Okay. You could do quadratic formula, I guess, too. You could have done quadratic formula. You just would have to remember it. Well, the problem is you got to get X totally alone. And right now, these are 2 different terms, so I couldn't get them together any other way than factoring. No, I can't do, well, okay. I could do a radical, but then aren't I stuck right back here without any answer? See what I mean? Yeah, if I have I don't have any in this one. If I had an X squared with just numbers, I could do a radical, like last chapter, some of the easier ones. But yeah, as soon as I have a quadratic with all the terms, I'm kind of stuck either quadratic formula, complete the square, or factoring with the X method. And this one, I wouldn't do complete the square. Some of you, I know you're super good at it, but half of 3 is like 1.5. That's messy. Complete the square is not super gorgeous or not super fun if it's a fraction. I'm not saying it's impossible, it just probably isn't the best way. And the nice thing is, on tomorrow's test, if you have one of these, the point isn't like hard factoring like last chapter. So I'm going to give you like a nice X method one that works. I'm going to give you a nice X method one that works. We end up with X minus 4. If you put it in your table, you would have been able to pull out. Miss Elbow is teaching Algebra 1 AB, I think, right now, the table, and they're loving it. They're loving the chart. Not that everybody has to do it that way, but it is super nice. And you end up with, let's see, negative 4x and 1x. So x comes out, negative 4 comes out, and 1 comes out. So either way. But remember, you're not done yet. Would you get the right x's at the very, very end? What are they?
4.
Good. Flip the signs. And if you don't remember that when you look inside, it's opposite what you think, you could have done it the Moses splitting the Red Sea way and actually added the 4 to both sides and subtracted the 1 to both sides. Whew. All right, we got through 10.3. Now let's go on to 10.4. Remember, this answer key is online. It's not with me as far as explaining everything. Oh, wait, but the video from today will be. And I didn't check all of those just because I did it in my head to check for you. The checking is on the answer key if you guys want to see it. Last but not least, the idea of inverse. And if I were you with your colored pen or highlighter, I would circle the word switch. Right? Isn't that the most important word for inverse? I mean, there's important stuff for the graphs that we skipped, like fold or reflect across a diagonal line, but for us, remember, we're just focusing on switch. So, if you want, you can even, well, they aren't exactly my steps. My steps are a little bit easier, but I do say to set y, I do say to switch x and y, and then technically, remember in the notes, I just say to solve. So my steps are set y, and then switch x and y, and then solve for y. Those are my steps. But when you guys did these bottom ones for number 17 and 18, what's all that you had to do to solve those ones, right?
Them.
Yeah. So X's and Y's. Whoop, 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 whoop. And then inputs and outputs. Whoop, right? Just switch them. That's all you gotta do. So I'm not necessarily gonna write all these because they're in the answer key that'll be on Google Classroom, but we're literally just switching those. But what's going on down here? Did you guys have it crossed out? The graphing part? Okay. What's the first step you did in 19, 20, and 21? Set each f of x equal to, right? So that then you could go ahead and what's step number 2? Switch x and y. Now you just have to properly undo with reverse PEMDAS, aka just solve. So subtract is the first step. Now, those of you that really, really, really want to do something crazy illegal, what is all you're supposed to do when you do x minus 10? Yeah, that's it. There is no combining. They are not like terms. This is multiplication. A few of you got really stuck on this in class. It's not minus, it's multiply. Negative 5 times. So divide. Good catch. Divide by what? Can you divide by anything else? You can divide by the negative 5 and get it all the way. Now, for tomorrow's test, is this right?
No.
Is it right though?
No.
Is it right?
Yeah.
Yes, it's right. Would it look like the back of the book's version?
No.
No. But for the test, I'm the one grading it. Just stop. Just stop. Now, technically, it's a little bad to put a Y. So I might have, like in an answer blank, I might have a G of X. Don't be thrown off by that. Just plug that in. You're fine. But for those of you that were trying to make it super snazzy like the back of the book, there are other ways of writing it. You could have brought that, bless you, that negative up. You could have done it like that. Or you could have actually made it look the nice clean version, like the back of the book. Any of those are right. All of them are right. But for tomorrow, why not just stop and be like, she's going to mark it right. And then there you go. Okay? No stressing. And the only reason I scribbled out the Y is because if you guys were checking, they're writing G of X because remember, they're not using the super snazzy Algebra 2 notation of F inverse of X. They're not using that. I mean, if you want to be snazzy, you can put that in the test too. Might be worth a bonus point just for being amazing. But you're amazing even if you don't go try it. Please study though. To do amazing. But just don't be thrown off. And you'll see it on the practice test. I wrote the whole G of X because that's technically what we're supposed to be doing. So guys, I'm going to do these real fast just because you were supposed to do them last night. And if something is weird, just let me know. I'm switching the X and Y, adding the 1 to the other side, dividing the 3 to the other side. Don't I have to take like a square root to undo that square root? To undo a square root, we do a squared. And this is review from last chapter. To undo a squared, we do a radical. Yeah, some of you might have gotten stuck. This is like a trickier one. But now, I mean, okay, we do have the absolute value of y. I don't know if I will totally take off points for that tomorrow. I might not. But here's the long story short. You're technically, remember, an absolute value gives us a positive and a negative. So this is the best way. And actually, I'll let you stop there. The back of the book might do some simplifying. There's a fraction. We're technically not supposed to leave it like that, but this is fine for tomorrow. Armando, where did I lose you?
Where does the 3 go?
Oh, I was jumping steps. So let me come back and show you what I did. I added 1. And the same way I didn't show that, I divided it. I was just going fast, thinking that you guys might be able to skip your steps and see where I was headed. Because remember, this was homework last night. Okay. But these two got tricky. This one you had to take a square root, and there was that plus or minus because of the absolute value thing. There were 2 answers. If you missed that tomorrow, I think a little half point or something. Nothing big. But it's good for you to highlight right now and be like, oh, okay, come on, brain. If I square root is squared, you've got to remember 2 answers, plus or minus. And then number 21, switching x and y. X equals 1/2 square root of 2y plus 6. Would you start in the right spot? the first way to get to that y? Okay, divide half is probably the best way. If you square it, I'll show you what you could have done to legally square it. I think a lot of you would have made a mistake with squaring. Oh, I did already, sorry. I did that real quick at the beginning. And then you switch the x and y, right?
Okay.
There you go. No, it's okay. Technically, we're not supposed to, like even from earlier, we're not supposed to square a square root until it's alone. Is it alone yet? No. Now, you guys are saying divide by a half, and that's good, except I'm trying to drill into you. Dividing by a fraction is messy, so just think about dividing by a fraction is multiplying by. Now, if you don't like that it's so separated, you technically could write this much closer to the 1/2 if you want. You just would have to realize I need some space. You can multiply by 2 over 1 right here, and you can multiply by 2 over, wait, what is 2 over 1? Just 2. You can multiply by 2 over 1 right there, and it's a lot easier to see that everything just reduces. That might look like cross multiplying. I apologize if that confuses you. I'm just reducing 2 over 2 and 1 over 1. 2 over 2 and 1 over 1. Basically, guys, we're going through everything you need to know for tomorrow. So then, there you go. Does that look better for reducing? That would just be 1. 1 times anything is itself. Now I can square both sides. For those of you guys that might have squared at the very beginning, here's the funny part. Here's the funny part. If you guys are worried about Isaiah's grade, you can make sure he's awake. But he's listening to me. I just saw his eyes. If I squared right here, and Andrew, I know I haven't switched the x and y yet, but if I squared right here, technically this would cancel out, but this would have become a 1/4, and a lot of people would forget to do that. Because it would be 1/2 square root times 1/2 square root. You'd have a 1/2 times a 1/2, which is a 4th. Some people would forget to do it here as well. But I think more people would remember that 2x times 2x is 4x squared than the people that would remember to make that a 1/4. That's why I thought that was kind of dangerous. Yeah? Okay. What do we got? Yeah. Did you hear me just say it? 2x times 2x. I have to square both sides, which means multiply it by itself. Did you put your parentheses? 2x times 2x will be 4x squared. Does that make sense? And then we have 2y plus 6, and now hopefully you guys are like, it's just algebra. Subtract the 6. Can't combine. Divide by 2, and if you're really, really, really snazzy, you might even know that 4 over 2 is 2 and 6 over 2 is 3. You can look in the answer key for maybe the better way of writing this, but kiddos, realize you can make that a g of x, same thing. Realize that would have been perfect for tomorrow, and I would have given you full credit on it. I wanted to make sure that everyone was able to completely tune in to the skills practice answer key and to see if they understood last night, or if they needed to ask questions, or if they needed to correct something on the skills practice. Yes, the full answer key is online. Now you have a video of the full answer key, but we have 14 minutes left of class. As I come around to grade those skills practice worksheets, you're going to try to bust out as much as you can and see what you know. Tonight we're going to keep working on the practice test with the answer key on Google Classroom. For right now, you can ask me questions like, I don't know how to do this problem. I'm going to get it wrong tomorrow unless I figure out how. Does that make sense?
Yes.
Ready, set. This is homework tonight. Treat it like a test, but you can leave out your skills practice. I'm going to come around and grade your skills practice and get you guys points. My advice, take this like a test and see what you get stuck on so you can ask me about it now. best you can on it. If you get stuck, raise your hand and leave an answer to the whole class. This isn't a test yet. It'll be tomorrow. Seeing what you get stuck on by your phone. But look, I watch it. It's easy. Let me get through everyone's practice test grading. You guys can talk, you guys can explain, you can talk to each other, but you can also just be taking it like a test and seeing how well you're doing. Or seeing if you know what to be doing.
Yeah, I think so.
Maybe just finding the domain in the radical of grading would be x minus 4 is greater than
This is good practice for tomorrow, yeah?
and then you just
You don't make it to so I would think it would be the opposite of that. I need help explaining. So how would you
We did it together just a second ago. Maybe Andrew has it for you. You can't work together on a test tomorrow, but you can work together on the practice test. Alexis, I still have them back here on the board. So these homeworks, and then the worksheets are all in 10-3 and 10-4. There's a puzzle time and then 10-3 and 10-4.
Right.
Some of you usually have questions on test day. Try this now and ask me now. I can answer everything and anything today. I just can't answer everything and anything during the test tomorrow.